So we should be, what's probability of A or B? They gave it to us. What is it? 0.70, right? So here I'll circle them. This one is this one, right? This one is that one. And this other one is this guy right there, right? Just plug them all in. Equals 0.32 plus 0.54 minus probability of A and B. And then, how do you solve this? First you combine like terms. Right, let me draw my little railroad for success down the middle. So we split those up. Combine like terms, and we will get 0.70 is equal to 0.86, minus probability of A and B. So if you have 86 cents and you subtract, you spend some, and then you're left with 70 cents, how much have you spent? You had 86 cents, you subtract off some, you give some away, you end up with 70 cents, how much did you give away?
0.16.
0.16, 16 cents. Everybody on board with that? So that's how you know that this is 16 cents. Or you could subtract 86 cents on both sides and multiply by -1. You get there either way. So here we're going to get probability of A and B is equal to 0.16. Well, you get negative this is equal to negative that. So you multiply both sides by -1 and you get this is equal to that.
Okay.
Yeah. Because this is still negative. Right? So if you subtract 86 from both sides, you get negative, which is the same thing as positive.
Okay.
Yeah. Do you guys want me to do that? I can do the steps. Would you prefer I do the steps? I'm okay with that. Would people like me to do those steps? Walk them out? Okay. So we will subtract 86 cents from both sides. And we'll end up with negative 0.16 is equal to negative probability of A and B. And then just, I think you guys seem to like dividing by, so let's divide by -1 both sides. So then we end up with positive 16 cents is equal to positive probability of A and B. Good?
You did that because you can't have like a negative probability, right?
Well, it's because we want to solve for this, not the negative this.
So
I don't want to say, well, what's the negative probability of A happening? I just wonder what the probability of A happening is.
So maybe I'm confused, but where does the -1 come from?
I got a negative number here. You know what? Let's do it the easier way. You guys are gonna. We'll do this. We'll avoid all the -1 stuff. We'll just do it this way.
Thank you for
We'll do this. We're going to add. We're going to add probability of A and B to both sides. So we'll get 0.70 plus probability of A and B equals 0.86. And then we'll subtract 70 from both sides.
Oh,
0.70.
makes sense. I see what you
So then we end up with probability of A and B is equal to 0.16. There. Is everybody happy with that? Okay. Good deal. Yeah.
So I got the same number,
Uh-huh.
however, instead of putting the 0.70 on the left side of the equation, I put it on the right side where the...
But you can't do that. It's wrong.
For this problem,
So you can't flip, I mean, you could add this to both sides and subtract that from both sides.
No, I mean, I just put 0.32 plus
Yeah.
0.54
Uh.
minus 0.70.
Right,
For this, it works, but will it
right.
work?
It will not always, it will work if your probability of A, or if you're talking about probability, so basically, what you're doing there is you're just rewriting the equation. But if you're starting from the top equation, then you need to do it this way. So what you've done is you've sort of solved it for probability of A and B first, which isn't, does that make sense? So
Kind of.
you, without realizing it,
Okay.
you just did it that way, which, it will always work. Yeah,
Okay.
yeah. So that, it's just not a multiplication, it's not a formula you guys know that you can start with.
Okay.
Yeah. Let's take a look at quiz problem 4, drawing marbles. So you could have done any of a couple different ways. Here is the quickest, easiest way. Well, I'll give you the, actually, we'll do the longer, harder one first. So you could do it like this. Right, so I could have I have 5 marbles, red, red, blue, 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 right? And then from each of the reds, I have a red, red, blue, 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 yeah? And then off the blue ones, I can have room, I could continue that on the next page. Here, this is sort of the way we originally did the boys and girls and stuff like that, right? Red, red, blue, 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 off of each of those. The other way you guys can do this, you guys heads up, if you did it this way especially, focus now, because this is how you need to do it in the future. This takes up a lot of paper. We're going to have one later that has 9 and 10 marbles in it. You're going to end up with 90, which is going to take up a lot of stuff. Instead, take the 2 reds, make them into 1. Take the 3 blues, make them into 1. So here, these guys are all equally likely. We will make it so they're not equally likely, but it'll be quicker, more efficient. Make sure I have these in here. Okay, good. So here, I've taken, how many reds do I have?
2 out of 5.
2 out of 5. Perfect. So the probability of going to red is now they're not equally likely anymore. 3 out of 5. The second red, again, 2 out of 5. Because they're with replacement. Blue is 3 out of 5. So now, the probability of getting here is not 1 out of 4 anymore, because they're not equally likely. Do you guys see what I'm saying? Before, we could just count how many, there's 4 outcomes, 1 out of 4, 1/4. No, you can't do that anymore. Why? Because now they're no longer equally likely. Does everyone follow? This is 2/5, this is 3/5. They're not the same. They're not all half, equally likely as each other. So now, in order to find something, we have to multiply along the branches. So if you remember, incidentally, I've spent like 3 hours making this slide. Like making it and then revising it and then revising it and revising it. So hopefully it's clear now. You start off with a river that flows, right? It branches, 1/3 to red, 2/3 to blue. You go along the little third that goes to red. Right, this third, this is the whole river, this is the third of the river. That river branches 1/3 to a second red and 2/3 to another blue. But it's not 1/3 of the whole that goes to the second red, it's 1/3 of 1/3 of the river, because they've already branched once. Right, so you're only talking about that little bit of the river, not, it's 1/3 of 1/3 of the river. So again, 1/3 of 1/3 of means multiply, 1/3 times 1/3, 1/9. This one here, 1/3 of 2/3, 1/3 times 2/3, 2/9. This one here, 2/3 of 2/3, 4/9. Not equally likely. These are not all 1/4. See how they're all different? More likely, least likely, because these are all not equally likely outcomes. Good. All right. So this is the clean, easy way that you're going to need to do trees in the future. So the long way was great for learning And if it's simple, it's totally fine. But once you get into like more than 2 draws and more than like 3 items, it becomes a big giant bear. So now we need to go with this combining them. So your question was, what was your question? Your question was probability of red than blue, was it?
Yeah.
Yeah.
Okay. So how do you get right here? And how do you get right there? You multiply the probabilities, right? Because remember, that multiplication rule. So it goes back to this one. And we multiply. I draw red, and then I draw a blue. Red and a blue. And we multiply. So it's going to be 2/5 times 3/5. So just as a reminder, when you multiply fractions, you multiply the numerators. 2 times 3 is 6. Multiply the denominators. 5 times 5 is 25. Now, what if you did it the other way? You would have said, okay, red then blue. Red then blue. That's this guy, that guy, that guy, that guy, that guy, that guy. Over here, none of those. So it's going to be 1, 2, 3, 4, 6 out of 5, 10, 15, 20, 25. So either way, you still get 6 out of 25. Make sense? Okay. But from here out, it's going to be easier to make it combine these guys. All right, so where we come with this is the idea, like someone was saying before, how do I know when to add and when to multiply? This is the rule. Ors, you add, right? And you think back, just what's the probability I draw a red marble or a blue marble? You're going to add them. You know what I mean? What's probably I spin a red or a blue, or what's probably I pick a yellow puppy or a chocolate puppy. You add them. So ors you add. And subtract the overlap if there's overlap. And you multiply. All right. So here we have an example. Let's get a reader. I'm tired of talking. Ivana, read. Great. So, this is what's going on. We're picking people. What's the probability that she suffers great stress at least once a week? What is that? 46%. What's probably she suffers great stress at least once a week? What's probably she suffers great stress at least once a week? Great. Now, I want to find the probability that she does, and she does, and she does. And we multiply. So because it's 46% of 46% of 46%, right? Only 46% passes first test. Of that group, only 46% more go on, and of that group, only 46% move on to what I'm looking for. So 46% times 46% times 46%, 0.097. Now, you might say, well, yeah, but we're not replacing the people, so shouldn't that make the number smaller? Here's the deal. How many people are there in the United States?
330 million.
Yeah, over 300 million people. If I take out 5 or 10 or even 100 people, is that going to change the percentage of 300 million? No. 1 out of 300 million is like 0.000000001, right? It's small. So if I take 1 or 10 or even 100 or even 1,000 out of 300 million, it's not going to change that percentage at all, that 46%. I'd have to take like maybe 1,000th or 10,000th before it affects that. So a 10,000th of 300 million, 300,000. It'd have to be like 30,000 or more before it starts affecting that number. Does everybody understand? Like just the handful I'm taking is not going to affect all the United States. Good? So that's why this number doesn't change. Now later on, we're going to talk about just 10 marbles or just 30 students. And then taking one totally changes it. Because if you have 30 students, each student is like 3% of the class. So if you take one, then all of a sudden that percentage drops by 3%. You know what I'm saying? So if you're talking about a class of 300 or 100, then that's different. If you're talking about 15 marbles, that's different. If we're talking about millions of people, like all of California, like all of the United States, totally 10, 20, doesn't matter. It doesn't affect that number. Good? All right, so you guys do your lab problem number 5 in your worksheet.